Still in chapter 6, talking about exponents, and today we're going to approach our final two exponent rules that we will be talking about in this chapter, and that is the zero and negative exponents. So when you are done with this lesson, you should know how to operate with zero exponents and with negative exponents. So the first one we're going to approach is the zero exponent rule. The zero exponent rule simply says a to the zero is equal to 1. In other words, any base raised to the zero power is 1. Now, the key here is to know what is the base. Also, as you notice, I just said other than 0. You cannot put 0 in for the base and still get 1. So understand any base other than 0 raised to the 0 power is 1. So for example, if we look at this, we have x to the 0, and since x is the base, we are raising a base to the 0 power, it would equal 1. Now, the question is, why does this work? Well, in order to explain that to you, we're going to go back to two different things. The first one that I'm going to go back to is the division rule. Remember, the division rule of exponents simply says you take the base x and you raise it to the 4 minus 4, which in turn would give you x to the 0. Also, if we go back to the basic definition, x to the 4th means x times x times x over x times x times x times x. Now, when we look at those x's like that, remember we can simplify. So x over x simplifies to a 1, x over x simplifies to a 1, x over x simplifies to a 1, and x over x simplifies to a 1. So 1 times 1 times 1 times 1 equals 1. So therefore, these two things must be equal to each other. Okay? So how does this look in some problems? Well, the key here again is making sure you understand what the base is. So when we look at this first one, the 6 is my base. So 6 raised to the 0 power is 1. On this second one, the x is the base. So x to the 0 is 1. On this third one, negative 4, because it's in groupings, is the base. So negative 4 to the 0 is equal to 1. Okay, now here's where it starts to change a little. So when we look here, the base here is just the 8 because it's not in groupings. So this is negative 1 because the 8 to the 0 would go to a 1, but the negative is not part of the base. Number 5, here you look, the base of that exponent of 0 is x, so that would go to a 1, so this would end up being 6 times 1, which is 6. On this last one, since there's groupings, that whole thing is the base, so that whole grouping raised to the 0 power is 1. Okay, so as you can see, you have to be very careful with what is considered the base. Okay, now next thing we're going to talk about is the negative exponent rule. So now when we look at the negative exponent rule, what it simply says is a to the negative x is equal to 1 over x, or 1 over a to the negative x is equal to a to the x. In other words, any base raised to a negative exponent switches its location in the fraction. Just the base switches, nothing else. Whatever is being raised to the negative exponent, that is what moves in the fraction. So if it was in the numerator, it will go to the denominator. If it was in the denominator, it'll go to the numerator. Now, one big key here, because we see this all the time. Highlight this, mark it down, whatever. A negative exponent does not have anything to do with a positive or negative value for the coefficient. That is a common mistake. A negative exponent just switches its location in the fraction. It does not do anything at all with whether the coefficient is going to be positive or negative. Okay, so here we go then. So examples of negative exponents. We start off my base here again. I have y to the negative 2. So y to the negative 2 would end up being 1 over y to the second. Y to the negative third, the base is y, it's in the denominator, so it would come back to the numerator and simply become y to the third. Here on number 3, the x is the base, it's in the denominator. The 6 is going to stay right where it is. It's not being raised to a negative exponent at all. It's not a base of a negative exponent. So it's going to stay right where it is. And this x to the negative 4 is now in the denominator. So it's going to move to the numerator and become x to the 4th. Okay, so those are the first 3 there. Now on this next one, you'll notice all grouping is being raised to a negative exponent. So that entire grouping is the base. So the first thing that's going to do is that's going to flip that entire fraction. So it looks like that. It's going to go x to the third over 2, and then we square it. Now we're back to our old rules. So we're going to take that 2, and we're going to take it to each item inside that grouping. So it'll end up giving me x to the 6th. Remember, we're multiplying. And then 2 squared. And 2 squared is 4. So we end up with x to the 6th over 4. Okay, in the second one, in number 5 here, we start off, the base is just the x, not the 4. So the 4 is going to stay right where it's at. The x to the negative 3, it's a negative exponent. It's in the numerator to start. It's going to go to the denominator and become a positive. Okay, on this last one, when we look here, we have an x with a negative exponent, and we have a y with a negative exponent. Okay, so what we're going to do is switch the positions. So on these types of problems, I like to start off with just the x and the y and where they're at. So x to the negative 2 is going to go to the bottom, become x to the second. Y to the 5th is going to stay right where it's at. X to the third is going to stay right where it's at. Y to the negative 4 is going to go to the top and become a positive. The last thing we're going to do here is we're going to take these, and remember now we have common bases, so I'm going to add my exponents and I'm going to add my exponents. So this ends up giving us y to the 9th over x to the 5th. And that's how we handle negative exponents. Now, let's try putting several things together now. The other thing I want to mention to you here is, what does it mean to be simplified? In other words, how do I know if I am done? Well, there's 3 simple rules that we kind of abide by, and that is no negative exponents. That's number 1. So if we have negative exponents anywhere, we cannot leave them in our answer. We have to move them around and simplify. The second thing we can have is no common bases. Now remember, that word common simply means that it is the same, right? So no common bases mean in my answer I can't have 2 different x's. I have to put the x's together. I have to put the y's together. I can't leave them as separate. And then the third simple rule that we like to follow is no numerical bases raised to an exponent. Which means you can't have any numbers raised to an exponent. So like, for example, you can't leave your answer as 3 to the third. You actually need to multiply that out and get 27. Okay, so with that, let's try some. So we're going to put this all together here. So we start here on number 1. I look and I see a negative exponent. Now, the first question I ask is, what's the base of that? And it is that entire numerator, because it's in groupings. So the first thing I'm going to do is I'm going to move all of that. So right now in the denominator, I have 4x to the 5th. That's not changing. That's going to stay right where it's at. Also, I'm going to move down negative 3x to the 4th squared. Well, in the numerator, then, that means I have a 1. My next thing I need to do is I'm going to take this, and I'm going to take that exponent of the 2, and I'm going to take it to everything inside of here. So with that, we're going to have 1 over 4x to the 5th. Then we look, what is negative 3 squared? That's 9. X to the 4th squared, that's x to the 8th. So now I put that together, so I have 1 over, and I'm going to take 4 times 9, which is 36, x to the 5 times x to the 8th, which is x to the 13th. Because remember, we take those two exponents and we add them together. And that would be my simplified answer. All right, let's try number 2 here. So when I look here at number 2, I'm going to start off, and what I like to do is I like to simplify everything I can inside there first. So I see the negative exponent, but I'm just going to leave it for a minute. So what I'm going to do is I'm going to draw this, and I'm going to leave that as negative 3. So the first thing I'm going to do is I'm going to start simplifying what I can. So 8 and 12 both have a 4 that go in, so that's going to be a negative 2, and that's going to be a 3. The next thing I see is I have x to the negative 4. So that's going to move that to the bottom and become x to the 4. Y to the negative 2 is going to move to the bottom and become a positive 2. X to the 6 is already in the bottom, and y to the 4th is already to the bottom. Okay, so those have those negative exponents, so that moves it. The next thing I'm going to do now is I'm just going to simplify that a little bit further. So I have negative 2, 3. Now remember, I'm going to take my x's and I'm going to add those together. So that'd be x to the 10th. I'm going to take my y's, I'm going to add those together. That would be y to the 6th. And I'm going to raise that to the negative 3. The next thing I notice is now I have that negative exponent. And remember, all of this is still the base. So what that negative exponent does is that flips that entire fraction. So it's going to end up giving me, didn't start off flipping, did I? I'm going to start off and I'm going to go 3x to the 10th, y to the 6th over negative 2. And now we simply cube everything. So I'm going to take this third, and I'm going to take it to everything. So the first one, I'm going to start off 3 to the 3rd. Remember, that's not 3 times 3. That is 3 times 3 times 3. 3 times, and that is 27. X to the 10 to raise to the 3rd, we multiply those, so that'd become x to the 30. Y to the 6th to the 3rd becomes y to the 18th. And then negative 2 to the 3rd would be negative 2 times negative 2 times negative 2, which is negative 8, and that would be our final answer. You are also welcome to write that negative up on top if you want, or out in front if you want. So either of these answers would be an acceptable answer at that point. All right, and that is our final exponent rules for this chapter.